Hello students, this is another video on the atomic structure and I hope it will be found useful by those students who are studying in grade 6, 7, 8, 9 and even 10, as they will come to know how electrons revolve around the nucleus. I have made a video using the first 5 atoms in the periodic table, and I hope that will make your concept clear as to how the electrons revolve in their shells. So welcome to this presentation as we go to the first atom, hydrogen, and here it is. You can see that there is one proton in the nucleus and one electron in the nearest shell, that is the K shell, and the electron is revolving around the nucleus. This is another moving electron video of helium, which has atomic number 2 and atomic mass of 4. We have shown where is the proton and where is the neutron in the center of the uh, of the atom, and 2 electrons are revolving around it. I hope this clears your concept as to how electrons revolve around the nucleus. This is lithium. Atomic number is 3 and atomic mass is 7. The yellow ones are protons and the brown ones hidden in the background but can be seen very clearly are the neutrons. And we have 2 shells. You see, I have drawn the 2 shells at right angles to each other with electrons revolving in it. There are 3 electrons because atomic number is 3. So number of electrons is equal to number of protons. So 3 electrons revolving in K shell and 2 electrons revolving in the K shell and 1 electron in the L shell, as you can see. This is beryllium, atomic number 4. Protons are 4 and therefore the electrons are also 4. In the first shell, which is the horizontal one, we have 2 electrons revolving, that is the K shell, and in the L shell we have another 2 electrons revolving. So atomic number 4 is beryllium, and this is boron, atomic number 5 with 11 nucleons in the center here, and you can see that there are 2 electrons in the K shell and there are 3 electrons in the L shell. The L shell is continuously getting filled up till it reaches its maximum number of 8 electrons. But this is the last atom that I have shown here, in which we have 2 electrons revolving in the K shell and 3 electrons revolving in the outermost or valence shell that contains 3 electrons, and therefore the valency is also 3. Now this is the structure of hydrogen molecule. This is the structure of hydrogen molecule, and these electrons will revolve. These electrons will revolve around the 2 atoms. You see, the overlap has taken place here, and therefore you can see that 2 electrons are at some point or the other belonging to both the atoms. So this is the formation of hydrogen molecule. I hope you like the concept. Now let us quickly move on to a pi bond and a sigma bond. Now this is the sigma bond formation of two p orbitals bonding head-on or overlapping head-on. So this is x, px, and this is pz, pz overlap. And you can see the extent of overlap is very great, and that's why this leads to the formation of a sigma bond. We can see that the nuclear axis is perpendicular to the orbital axis or orbital axis. This is s orbital, so two s orbitals will overlap, forming a sigma bond, whereas two pz and pz orbitals over here are overlapping sideways so that the internuclear axis is perpendicular to the orbital axis, a bond axis. This is the bond axis over here going. This is the bond axis going straight up or straight down, and this is the line joining the two nuclei of the two atoms in which a pi bond is being formed. You can see that the overlap takes place above and below the nuclear axis, and that is the formation of one single pi bond. I hope this video clears up the required concepts of pi bond and sigma bonding by different orbitals. In sigma bonding, the overlap is great, and therefore the sigma bond is stronger as compared to the pi bond. Also, the pi bond is, you see, jutting out of the molecule, so it is vulnerable to attack by attacking species, and therefore it breaks much before the sigma bond breaks. And thanks for watching.